What? If you don't mind just muting yourself, please. Right, let's start. All right, guys, let's start off with the first question over there. But it's actually 1.1. The question is cut off. I want to just tell you what the question is orally. Somebody's got their mic on, please. If you don't mind putting your mic off. Thank you. All right, let's start. The question for number 1.1 is which of the following compounds is an aldehyde? You may just give us the answer if you know it, please. Which one is an aldehyde? Don't feel shy. I'm going to wait for someone to give me the answer.
A.
Okay, whoever said A, you want to provide them with a reason, please?
Because at the end it's CHO.
Very good. You are supposed to know that the condensed structural formula for an aldehyde will end in CHO. If it was COH, it's an alcohol. CHO is the condensed formula for any aldehyde. So the answer there is A. Which one of the following is a correct general formula for a carboxylic acid? That's the last compound we dealt with. Anyone? General formula for the carboxylic acid? The answer is C, CN, H2N, O2. Alright, you guys are good at this. What is the IUPAC name of this compound? Somebody else, please, apart from Mr. Peer. There's a lady over here. Maybe you can give us the answer.
It's A, sir.
It's A. Correct. It's 2,3 dimethyl butene. You start from, well, you can start from any side actually. It doesn't make a difference. That's your main chain. 1, 2, 3, 4. On the second and on the third carbon, you got methyl side chains. So 2,3 dimethyl butene. A is correct. Please, I'd appreciate more participation. This is a giveaway, but it's 1.1 in the paper, so you can appreciate why it's so easy. The homologous series that contains carbon-carbon triple bonds. Triple bonds between carbons are? Sorry, I didn't hear that. Triple bond between carbons, gentlemen.
Alkynes.
Alkynes, yes, alkynes. Correct. C double bond O with the hydrogen at the end is the functional group for which compound? They've given you 4 names. So which one would belong in one of these? And tell me why, eh? Right, let's start off firstly with this here. This is the functional group of which group of compounds? C double bond
Aldehyde.
O. Very good. It's an aldehyde. C double bond O with the hydrogen at the end, or rather at the beginning, because it's the first carbon. That's an aldehyde. Which one of these is an aldehyde?
A.
A. Propanol. That's an aldehyde. What is, don't scream it out, the guy who actually just gave the answer, you don't say anything now. What is the name of the functional group of an aldehyde? We discussed this in detail on Friday.
A.
A.
4-mile, correct. Another one of your favorites. All right, somebody who hasn't answered, you want to give us a shot here? Do we start from the left or right, gentlemen?
Right.
Good. 1, 2, 3, 4. Which one do we name first? B for bromine, C for chlorine, and then lastly M for methyl. The reason why bromine comes first is not because it's in position 1. You're going to name the bromine first because alphabetically B comes before C, C comes before M. All right, what's the name?
A.
1 bromo, 2 chloro, 3 methyl butane. Correct, sir. It's A. That's it. We're done with the multiple choice. Right. Before I forget, now that most of you are here, so I noticed that quite a few in the class are actually keen on recording the lessons we have in school, and I came up with a better idea. So the lesson that I sent you earlier on is our next section after organic. It's vertical projectile motion. But if somebody wants, not somebody wants, please somebody upload this video. But I'm not sure if you can. I can give you all the lessons as it unfolds for vertical projectile motion. If you can group all of them together as a series of videos for vertical projectile motion, that will be great. This will be video 1, then video 2, video 3, video 4 will follow. Right? And then if you want to watch these videos again, which is basically the outlining the theory and the questions, it will be great. So if you ever get stuck and you want to go back and watch how we did certain questions or what was the theory behind some aspects that we discussed, you're more than welcome to do that as well. All right, so I've put up the first video for vertical projectile motion, which is the basic theory from the grade 10 work on displacement, velocity, and acceleration, which you're going to need anyway. All right, people. So as I said, I had to chop and change some questions. My class, because we did not do isomers and primary, secondary, and tertiary compounds yet, we're going to leave all those questions out. All right, so please just excuse me for now, but by next week, we'll be done with everything, plus we would have started off with the next part in organic. Right, let's see. Which one of the following is an alcohol here? Do not scream out the answer, because I'm going to ask you for the reason. If you're certain of it, then you may go for it. And you can provide us with the reason. I know somebody already knows the answer, so just go for it now.
D, because the general formula for an alcohol is CnH2n plus 2O.
Good, it's D. For those of you that don't know why it's D, it's D because the general formula of an alcohol is CnH2n plus 2O. What's the other general formula, boys? CN H2N plus 1 OH, which is not here, obviously. This fits the bill. You take your carbons, you double it, you'll get 8. You add 2, you will get 10. And there's a single oxygen there. Now, I already answered this. So which one is the 4-mile group here? And give me the name of the compound with the 4-mile group. Right, boys and girls, that's your 4-mile group. C double bond O and a hydrogen at the beginning of the compound. What's the name of A, anyone? 4 carbons is
Butanol, sir.
Very good, butanol. So the one with the 4-mile group is A. I want to explain this now in this lesson because this is self-explanatory and it's quite easy. I never explained it before. I actually left some space above this. Saturated hydrocarbons. Saturated hydrocarbons are compounds that contain single bonds between carbons. So you have single bonds between carbons. Unsaturated hydrocarbons unsaturated means you have either double or triple bonds between carbons. So it's quite simple. Any hydrocarbon which has single bonds between them is saturated, which means an alkane is a saturated hydrocarbon. Unsaturated would be either an alkene or an alkyne. Unsaturated means you must have a double or a triple bond between the carbons.
Homologous.
All right, the person who came in last, mute yourself, please. Which one has a double or triple bond between carbons here?
E, sir.
Very good. You gotta tell them whether it's a double or triple bond because some of them can't see it. Whoever gave the answer E is correct. But would you want to tell them how you got E? Because they don't know some of them. I'm guessing you did it because you drew it out. But the lack of hydrogens between two carbons indicates that there's a triple bond. Sorry, not there. The lack of hydrogens between two carbons means that you have to have a triple bond there. So if you draw E out, you quite likely will find there's a triple bond there. I want to start with this first carbon there, which is a CH3. There's the carbon. There's the H3. Then the next two, which are boxed in gold. Hey, you're not here to sing, Baba. You're a big boy now. C triple bond C. You got 4 bonds around the first gold carbon. You got 4 bonds around the next gold carbon. Then you're wondering what is the CH3 2 in brackets there. These are side chains. So this carbon here, that would normally have 2 hydrogens on it, there and there. Doesn't have 2 hydrogens. It's got 2 methyl side chains there. One CH3 there, and the other CH3 at the bottom. So there's your two CH3s attached to this red carbon here. And then at the end, you got a CH3 there.
So how are you
So what?
sure of the placement, sir? That is not the other way around.
What do you mean by other way around? So define, specify, describe other way around.
Like, how can we be sure it's not the CH3? Oh, never mind, sir. I think I see it.
Okay. Because if you actually put, or you mean whether the triple bond goes there, you mean? No, it could have not been there because this carbon here had nothing on it. That's how we knew.
Yes,
And
I
this
saw
carbon
that.
was the giveaway. Yeah. I know what you're asking. Because this carbon here definitely had no hydrogens. The triple bond had to start there. IUPAC name of B. So sorry, the unsaturated was E, as somebody pointed out. IUPAC name of B.
Three bromo, four ethyl, four methyl pentane.
I think that's wrong.
Sir.
Okay, how many carbons in the main chain? Because the other guy said pentane.
Sir.
Okay, let's start with how many carbons in the main chain, please?
6.
6. 1, 2, 3, 4. You forgot to go up. 5, 6. Now, you have a choice of starting from the top here. This is a hard one, by the way. Or starting across this way. What side do we start? Does it matter, firstly?
Yes, sir.
Good. Tell us what side you're going to start from, and then I'll explain the rest. Top or from the right?
From the right.
Actually, no, from the top.
So we start from the top because we have to give ethyl the lower preference.
There's no ethyl here. There's 2 methyls here. Anybody knows the reason why we start from the top again? Right, here's the reason. If you start from the top, yes, okay, go for it.
And so if you start, wait, no, so sorry, so it's a
Okay,
mistake.
let me explain it. It's fine. If I start from the top, my first 2 side chains will be 3 and 3 and then 4. But if I start from the right, it will be 3 and then 4 and 4. You start from the side with the lowest combination of numbers when you are naming. So you are going to start off from the side with 3, 3, 4. Not from the side with 3, 4, 4.
So, don't we disregard the numbering if we're dealing with special cases like bromol?
Only if your numbering is the same from both sides, sir.
Oh, thank you,
So
sir.
if the positions were exactly the same from both sides, then you are exactly right. So in other words, if it was 334, 334 from both sides, then the bromine will take the lower position. Right? But if it's one side got 334 and the other side's got 344, the side that has 334 will take the answer.
So even
you,
when
sir.
there's two bromines,
Okay, so the bromine will only come into play to take the lower number if the side where the bromine is from had the lowest combination of numbers. It's not the lowest from this side, sir. If you start from this side here, it's going to be 344. You start from the top, it's going to be 334. So the answer to this would be 4-bromo, 3,3 dimethyl, hexane.
So do we ignore the other bromo because there's two present?
Oh, shucks, I didn't see that. Oh, then you guys were all right. I was wrong. Oh, Baba, why didn't you tell me there were two bromines? I didn't see it. Then all of you said the correct thing and I said the wrong thing. My mistake, guys. Let's go back to 6. So there were 6 here, right? The person who said starting from the right, let's take your argument again. You got 1, 2, 3, 3, 4, 4, 5, 6. If I start from the top, 3, 3, 4, 4, 5, 6. If you look at the red combination, it's 3, 3, 4, 4. Sorry, this is the black combination. The black combination basically starts off from this side here. If you start off from the red combination, which is starting from the top, right, it's still 3 there, 3 there, and then 4, 4. You guys were right. The numbering was exactly the same from both sides. If it is exactly the same from both sides, then the special case applies, which is what you guys mentioned. Bromine takes the lower one, not the methyl. So it means bromine gets the lower number, not the methyls get the lower. Why? Because alphabetically, B comes before M. So it's going to be 1, 2, 3, 4, 5, 6. You guys were right. 3, 3 dibromo. 4, 4 dimethyl hexane. My apologies, gentlemen. I didn't see the 2 3s. Which brings
Yeah.
me to a very important point. We discussed this in class. If the numbering is the same from the both sides, then you must give the lower number to the alphabet that comes first. Okay, ask the question, please.
No, sir, it's okay. You just answered it.
Okay. Only if the numbering is the same from both sides, then you are right. You must give bromine the lower number. We already got E, yeah? E was not easy. These guys died last year, by the way. These guys died because if they didn't remember the special case for naming, they would have got cooked. And this was not an easy draw. Thankfully, we already drew E. There's E drawn for you. I want to tell you something about condensed formulae. If the examiner asks you to name a compound from a condensed formula, don't be a hero and try and get the answer from the condensed. It is exceptionally tricky to work with condensed formulae. Always err on the side of caution and draw it out first. So there's it drawn out for you. Can you give me the name? I'm going to make it a little bit bigger. If you think you know it, keep quiet. Let one of the other brothers answer if you've answered several times. If there's too much of silence, then I'll open it up to everyone. Even this, after you drew it, you still have to know your rules here. I can understand why the people actually suffered last year. Because this wasn't very easy.
So
Okay, anyone? Yeah, go for it.
4.4
Yeah,
dimethyl
right.
pent 2-ine.
Brilliant. Brilliant. You want to tell them why you had to start from the left and not from the
Yes,
other side, because some of them would have started from this end.
yes, sir. When starting you're numbering from the left, then that means it's the numbering is gonna be lower to like the number is gonna be lower with the bond.
You
The
mean from the
carbon
right?
no,
When
like
starting,
numbering from left to right.
no, if you start from left to
It's gonna
right,
make
your
no, I
bond
mean
will
from
go
right
to
to
a
left,
higher
sir.
position. Yeah,
Yes, sir.
from right to left. Yeah. If you
So
start from right to left,
numbering from right to left means that
the bond takes the lower position of 2.
yes, sir.
And the bond must take the lower position compared to the side chain. You do not start naming from the side closer to the side chain. You number from the side closer to the bond. So brilliant stuff, guys. 4,4 dimethyl pent 2-ine. Yeah, this was a horrible examiner, eh? Normally question 2s are easy. I remember last year, the learners actually complained about this question, yeah. Now I know the reason why. 3,3 dibromo, 4,4 dimethylhexane. All right, that was done. I couldn't have done the rest of it, guys, because they had some stuff on esters and isomers in most of these questions, so therefore I cut them short. But next week, in class, we will do questions that will include them. Actually, on Monday afternoon, which I'm hoping most of you stay for, I will complete esters, and we should be able to do a full-blown question that will have esters and some isomers in them. All right, is compound A saturated or unsaturated? And give a reason. Now you can answer that. You can look at it, you know whether it's single or double or triple bonds there.
It's
Come, you
saturated,
know it.
sir.
Good. Just by looking at it, give them the reason why it's definitely only single bonds. What's the sort of pattern for single bonds in an alkane?
The the central hydrogens, well, the central carbons have 2 hydrogens, and the outer carbons have 3 hydrogens around them.
Brilliant. Brilliant. All alkanes have their outer carbons with 3 hydrogens and their inner carbons with 2 hydrogens. That is the trend for all alkanes that have got no branching on them. So you could have picked this one out easily. Don't use that as a reason, right? So it's saturated. If they ever ask you why a compound is saturated, you will state single bonds between carbon atoms. unsaturated, you could actually give double or triple bonds as the reason. Which one is a ketone? Which one is a haloalkane? And we leave that one out for now. Which one is a ketone here?
E.
E.
Very good. The reason why it's E, for those of you that have forgotten, a ketone must have the carbonyl group, which is here, between two other carbons. The name of this here, gentlemen, 1, 2, 3, 4, is butane 2-one. You technically don't have to state the 2, but if you put it down, there's no harm in it. Which one is a haloalkane here? That's a giveaway now. Haloalkane?
D.
D. Write down the IUPAC name of compound D. IUPAC name of compound D. Take a minute, everyone. And somebody else except the regulars to give us the answer. The name of compound D. All right. One of the non-regulars, please. Give us a try.
So can I try?
Yeah. How many carbons in the main chain?
2,3 bromo, 5
Dibromo.
methyl hexane.
Okay. Start again. Sorry, I missed something there. 2,3.
Dibromo,
Right.
5 methyl hexane.
I think you're right, sir. I think you're right. Starting from the left. 1, 2, 3, 4, 5. Sorry, heptane. Thank you. 6, 7. 7 carbons, eh? Not 6. So 2,2 dibromo was correct. 5 methyl was correct. But heptane for the main chain, right? Methyl heptane is one word, eh? And I want you to all read this carefully. Name of the functional group, not the name of B. They don't want the name of B. They want you to identify the functional group in B and just give us the name of that functional group. So let's go to compound B. There's compound B there. What is the name of the functional group of compound B? I'm going to draw it for you. What is the name of the functional group of compound B? There is the functional group. What is the name of that functional group again?
Formal.
Correct. That's the answer. Not butanol. Many learners give the name of the compound, not the name of the functional group of the compound. They don't want the name of the compound. Please read these questions carefully because learners tend to make a mistake with these ones, especially where they're only asking them about the name of the functional group. I'm going to leave the next one out I just want to focus a little bit on these compounds here. Boys and girls, is A saturated or unsaturated? And tell me how you got the answer. One of the ladies, if there's a lady here. A clue, CnH2n. Saturated, single bonds between carbons. Unsaturated, double or triple bonds between carbons.
Or it's unsaturated.
Correct. And the reason?
Has a it's
It's an
so
alkene. Let's start off
it's an
there.
alkene so with a double bond
Between carbons, right? Don't just say double
between
bonds.
carbon.
Right.
Yes.
So let's go for it. Write down the letter or letters for a ketone over here. Which one's the ketone? There may be more than one as they suggested. Don't fall for it, please. Something may look like a ketone, but it's not really a ketone because it's a compound you didn't study. A
F.
ketone must... Very good, it's just F. Why F? There's your carbons. There's the carbonyl group between the two carbons. You may be wondering, what about the others? This is not a carbonyl group. You got C double bond O here, but you don't have a carbon there. You got an oxygen there. That's a completely different compound. Some of you may say, what about H? H is a carboxyl group. This is a carboxylic acid here. So the one with the carbonyl group, which is a ketone, is F. Which compound has a general formula CnH2n minus 2? Which one is CnH2n minus 2? And you're going to tell me why, yeah? It's glaring. It's glaring.
D. So it's D by observation.
D by observation, yeah. It's quite likely, where's the triple bond? Sitting there, isn't it? No, sorry. On the first carbon, isn't it? Why the
Yes.
first and second? Because that first carbon is supposed to have how many hydrogens on it there?
3.
It's got 1. The second one's got no hydrogens on it. The triple bond is there, definitely. It's D, correct. Okay, we already did this one. I gave it to you. The compound containing the carboxyl group, as I pointed out to you already, C double bond O, single bond OH, is your carboxyl group, which is the functional group for your carboxylic acid. This is 1, 2, 3, 4. This is butanoic acid with no side chains on it. So H has got a carboxyl group. Now I'd like to stop over here. And I'd like to just reiterate what I told you. You know, as a learner, you don't know what to learn in this section. And you also don't know where to focus your attention. Because even in class, the way we teach it, we tend to focus a little bit too much on the name and structure, but focus your attention on everything else. General formula, molecular formulae, condensed formulae, name of functional group, structure of the functional group, right? And obviously we're going to do isomers next. Focus on them because naming is a small part and drawing structures is also a small part in the section. IUPAC name of F. F. Somebody new, please. Okay, anyone? I know learners don't like ketones, so let's do it again with me. Identify your main chain. Your carbonyl group, you start numbering from the side closest to the carbonyl group. 5 carbons in the main chain, right? You got a methyl side chain here. So 3 methyl. 5 is pent, so it's pentan. Then the position of the carbonyl group, 2 own. 3 methyl, pentan 2 own. Okay, somebody with G, please. That's a sweet compound, eh? Let's give you another 30 seconds. Give the others a chance. I know some of you have already worked it out. All right. Anyone, please? Number of carbons in the main chain. Let's start there.
So can I try the answer, sir?
Yeah, go for it, sir. Number
So
of
is
carbons
it?
in the main chain first.
It's 6, sir.
1, 2, 3, 4, 5, 6. Side chains are bromo, 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 ethyl. Okay, go for it, sir.
So is it 2,2, 4 tribromo dash 3 ethyl hexane?
Brilliant. Brilliant stuff. You guys are masters at naming. No, 2, 2, was it 4?
4.
Yeah. 3 ethyl hexane. Tribromo. Then they want us to give the structural formula of compound B. Pentanal. Everybody should be able to draw pentanal, eh? Pent. And at the end, 4 mile. Pentanal for you. All right, guys, we're going to stop over here for today. Thank you for attending. I would have liked to have done more of these robust questions where we got isomers in them, but on Monday, we're going to finish esters in class and we should go pretty far with isomers as well. So in the afternoon, when you do stay behind, I'll have a few full-blown questions ready for you in the section. So we'll be ready to answer most of the questions in the section now. And you guys are pretty good with this. I'm going to put this up on the group chat. I'm also going to put up a PDF. If you want, you can start learning it now, of a summary of the homologous series, general formula, functional groups, names of functional groups, right? Molecular formula, how to identify compounds, and some very basic rules over there. So you can actually get started with the learning of some of the theory over here. Please stay for a minute. I just want to show you what that will look like. So you will receive this. Oh, what was that? So this is a summary for naming. There we go. So I'm sharing that. It's got everything on that one page. Right. Your condensed formulae, what they will look like for various ones, how do we name them, the structures, everything is there. Well, thanks for attending, everyone. We will now meet up on Monday afternoon for the next extra lesson and one during the break as well, the second break. We're going to start with some organic on Monday as well in the second break. All right, guys. Have a good weekend.
Thank you, sir.
Thank you, sir.
Thank you, sir. You too, sir.